And this is the agenda. I'm curious if anybody has anything that they want to add to it or move things around. Going once, going twice. Sold. So basically this is the working group status. We got the TLS downgrade SCSV draft is with the RFC editor. We have the TLS die draft is in last call. I think that's probably the wrong date, but this is 30 April. I think it's 30 March. And then we'll get that to Stephen. Hopefully that won't be too controversial. And then we have 3 drafts with our area director. So I think probably in the next week or two he'll be getting around to those and progressing them forward. Obviously in progress we have cached info, which maybe if Hannes is here he can give us a little brief update. We talked a little bit about the interim and he can tell us about the changes and what we're going to do with it. Yorona also at the end is going to, or Yov, sorry, is going to tell us a little bit about the 4492 draft, which is bringing the elliptic curve stuff to standard track. And then obviously we have TLS 1.3, which is going to be the bulk of our discussions today. In the wings, we've had at least a couple of requests actually going back almost a year now for some additional things. The one for the Cha-Cha draft. I basically sent to Cha-Cha on the 25519 draft. I sent a heads up to the authors that after we progress the other 3 towards Stephen, we're just going to basically have a working group call for adoption. So that'll probably happen in the next 1 to 2 weeks too. And that's based on our assumption of the MTI stuff. And then the other thing that we talked about at the interim in Paris, which was like 6 months ago, which Joe and I just dropped on the floor completely, was the TLS false start draft. So we'll have a working group call for adoption on that as well. And again, remember when we do working group call for adoptions, it's not like, is every word in here perfect? Is it a good starting point? We can go from there. And without further ado, pull request 107.
So agenda batch, we're swapping the 2 sales negotiations.
0 or 2T.
So that's what we're doing now?
Yeah.
Oh, we have backward compatibility full.
But yeah, backward.
Oh, sorry. This one.
Yeah.
So that's not the relevant bit. There we go. I'll put it up on the screen. Let's do it. So, Akra, how do you think we should try this?
Yeah.
I mean,
So, yeah, that's fine. So we've been going sort of back and forth on what, so Dave Garrett proposed to sort of try and narrow down some of that compatibility semantics. So as people probably know, there's like this basically superfluous version number field floating around in the record header. Everybody's sort of scared to remove it, and the reason we're scared to remove it is because there are stateful inspection devices which kind of counted being there, and other things like that. And we could put like unstunst in there, but whatever we put in there, if the length field isn't in this position, we're going to probably have some problems with anything that tries to even segment TLS packets. So I think people are terrified of doing that. On the other hand, having it sort of float around in there has turned out to be kind of a problem because there are all these places where it can get out of sync with the actual version of protocols negotiating. In particular, because when you sort of open up the client, hello, you don't know what version you're negotiating, so you put something in here, and what you put in here like turns out not to be the thing you sort of imagined you'd want to put in here, and then whatever happens if the version that you put in here is different from the version that you negotiate, well then you're supposed to change it, and so it also makes everybody kind of like crazy, especially because it can, as I say, it can get out of sync. So the proposal on the table is basically to nail this version down to 3.1 and have it just be a fixed 2 bytes that we're just wasting. We're wasting it anyway, by the way. So we're not talking about not wasting it. We're just talking about wasting it in a less confusing way. This has to be in the handshake. This record version, just to clear the variance, minimally has to be effectively in the first handshake packet from each side. Because if it's not in the first handshake packet from the client, the servers will absolutely choke. If it's not in the first handshake packet from the server, then it will be really a pain in the ass to write a switching client because you have to sort of dig around for like trying to guess. So you can imagine, as I say, being really aggressive and stripping it from later packets, but it's probably not worth it because you're only saving a little bit of data. As I say, the proposal on the table when we came up with the interim was just to nail this version down to 3.1, which is basically the lowest version of any TLS, which would be TLS 1.0. Anybody have heartburn about this? No? Okay, great. You scroll forward. Is there anything else in this PLL? Keep going. That's just documentation. Documentation. Yes, yes. Yes, yes. Yes, yes. Yes.
That's 3.4.
So that we obviously probably use. Right. But this is, so right, this however is not, this is the different one. This is the one in the handshake message, which is again why, hence the confusion. So the point being, this is the version that's going to move around and the other version will just be constant. Keep going. Okay, this is documentation. Documentation. I'm just making sure something else in here that we haven't seen. Yes, okay, so this doesn't matter, blah, blah, blah. Yes, that was outstanding stuff. Keep going. Keep going. Yes, I think we're done with this one. So I'm going to pull this in. I'm going to go over it by hand, and I'll pull it in unless somebody complains. It's in the next draft. Okay.
Great. And we got 7 minutes back. Now we're doing this.
Okay.
Sorry?
Yeah, you got big full screen.
Dink. Dink.
Next slide. Okay, so and then a big pile of changes in this draft since the last version, which I will go over incredibly briefly, and then we can talk about substantive stuff, especially since some of these changes are being changed again. Let's see, moving to the bottom, we got rid of point formats. We took Adam Langley's suggestion to update the signature with a context string, making it so you couldn't swap signatures in one context and signatures in another context. Renegotiation is now gone. You'll be hearing a presentation later today by Andre about how to return the most important feature of renegotiation, which is inline, most important and yet most distasteful feature of renegotiation, perhaps, which is inline client authentication. I messed up the handshake numbering, so I fixed that. Change safe respect vanished to, I think, people's happiness. The objective here is the state machine should always be so clear that you never need change safe respect to tell you what to do. Also, not having renegotiation makes the problem of change safe makes the problem of change safe respect you might have thought solved no longer really relevant. One hopes. And we pulled the extended master secret draft from the INRI guys and from Adam, et cetera, and Marsh Ray into this document. So now all the in this version of the document, though not in the version we're thinking about for the future, all the master secrets are derived directly from the session hash. In the version that we're sort of contemplating, all the leaf key material will be derived from the session hash, but not the master secrets. And Hugo can talk later about why that's a desirable set of properties if you want to hear about it. In the 05 draft, I messed up which master secret was used for exporters, so I fixed that. There was a typo and a bingo, and we pulled in this complete prohibition of SSL version 3 negotiation entirely. So none of this should be controversial. Pretty much everything important here is we can list, so it's just review. Next slide. So now we're talking about zero round trips. This has been hiding in the background, something we needed to get to. Once we got one round trip being nailed down, we're starting to get pretty close to that, so it's time to talk about it. Let me start with the overview of how everyone the consensus view of how this has to work. Next slide. So everyone basically understands that if we're going to make zero round trip work, essentially what we do is we're going to take all the messages that used to be like here in the second client flight and shove them up here. And that includes any application data the client would have sent on the second flight, and now it goes on the first flight as well. If you're only going to have one message going each way, it's kind of the way it has to be, although we can argue about how things get packed. So that's pretty well understood, and an obvious expectation. Next slide, please. Other thing that's pretty much well understood is what the crypto has to look like at a high level. The ideas in the space go back all the way to like Benet and Shockham, False Start, and Snapstart and Equip. But basically, you have to do is effectively some kind of key transport, where the client knows the server's public key. In some way, there's been advertised in like the DNS or it's from previous contact. For purposes of this discussion, let's assume it's from previous contact. And since we're only doing Diffie-Hellman or easy Diffie-Hellman now, and RSA is gone, what that actually means is the client knows the server's Diffie-Hellman share, and that Diffie-Hellman share is good for some reasonable period of time. It's not an ephemeral share. So the first flight, when it's sent, is enciphered under the pair of the client's ephemeral secret and the server's static secret, or semi-static, whatever you want to call it. I mean, so when I'm saying stable, I don't mean it's like for 2 years, but I mean it's for at least the time between the last time the client talked to the server and now, this isn't going to work. This first chunk of messages don't have PFS, at least if you think P means perfect, because the duration of that is for the duration when that server key is valid. Now, if the server is churning that key every couple hours or every day, then you have a pretty good, reasonable security guarantees, I suppose, but it's not perfect. As Adam would point out, if you're doing resumption, then the security guarantees of PFS were not obvious. This data gets something like this, and then the server has an opportunity to provide a real ephemeral value in his first flight. People sometimes call this the ratchet, the way it's done in like TextSecure. And so all the data the server sends and any data the client sends after this point is encrypted protected probably under both sets of secrets, i.e. the client's ephemeral is paired with both the server static and the server's ephemeral. And so you certainly could get away under some circumstances with only having the remainder under the server under the ephemeral pairs, but mixing in the server static also has security value because it means that if the server's ephemeral for some reason compromised, then and it's stored differently from the server static, you still have security. I'm assured by Hugo and other colleagues that this can be made secure under the right circumstances. You have to treat the key material properly. So again, this is like basically the only way anyone knows how to do this, so it's the way we're going to do it if we're going to do it. Next slide. So now we get to the thorny bit, which if you've been reading the mailing list, you know about. So TLS anti-replay presently is based on each side supplying a random nonce in the client random and server random. And so the way you know, and that nonce gets mixed into the key material. So the way you know that the data from the other side is fresh is because it includes key material derived from a random value you provide to the other side, and you know your random value is fresh, at least you hope you do. And so you know the data you're receiving is fresh. Obviously, in zero round trip, if the client is speaking first, any data the server receives cannot possibly incorporate any data the server has provided to the client. So the client has anti-replay from his perspective because he can provide a random in his message, but the server does not. So you got to do something else. This has also been known for a very long time, and for a very long time, for a reasonable period of time, we thought we knew how to do this by storing state on the server where the so next slide. So this is basically a technique that everyone thought was cool, going back at least as far as Snapstart and used in Quick, is the server keeps a list of all the client nonces, though the list is typically bounded in some way, like the server has a server cluster identifier, Snapstart calls it an orbit, where basically and you have a timestamp to basically, so you don't have an infinite size storage. So basically what happens is when the client sends, what happens is that the client sends the server his random value. The server tries to look up in a table, and if he doesn't have a copy of it, then he assumes it must be fresh and he keeps going. And otherwise, I don't think I have a slide list, unfortunately, but otherwise, basically, he just forces the client to fall back to the ordinary one-round trip handshake. Because that's how we plan to do it. There are slightly different ways to do it, but the details are not too relevant here. The thing that is relevant is that the semantic that everyone assumed we wanted from the application layer perspective was that the application could just stuff data into the pipe, and it would be delivered either in the first round, in the first message or the second message, and that TLS would take care of anti-replay, and that if the zero round trip failed, then it would just basically be retransmitted later. That's the semantic they wanted, because it's a semantic that preserves the existing TLS semantics. Unfortunately, it turns out not to work. Next slide. Unfortunately, we discovered this that the interim DKG asked how it worked, and we started to work through it, and it sort of didn't work. I'm going to give you the sort of a contrived example first, and then I'll show you the real example that really matters. So imagine we have some request from the client that has a side effect, like he's buying a pizza or something, right? That's the usual example. So what happens is the client sends an initial message to the client below in 0TP extensions, and it goes and it says, buy something. And the server, we're always assuming that the attacker has full control of the network, right? So the attacker in this case intercepts the TCP connection, and he forwards on this message to the server. So this is all perfectly normal. I mean, this is like the attacker just acting on the network. And the server processes the purchase and starts delivering the pizza, and the attacker absorbs this message. The client never sees it. And at this point, the client finds some way to force the server to reboot. So the server loses all its state. And so at this point, and bear in mind, the client has received no response, right? And now, once the server's rebooted, the client retransmits this initial message, right? And so the server wakes up and goes, I have no state. I have no read-like cache, so I've got to assume I can't accept this message, so I'm going to force the guy back into one RT handshake. So he sends back the server hello, he rejects it. At this point, the client completes the handshake, as we expect, and because remember the semantic I said is we want to have transparency from the application perspective, he retransmits the request to buy something. Now, the server, of course, has no state, so he processes it again. So now we have an anti-replay failure. So this is obviously not really desirable, and as I said, this is kind of a contrived example because you have to somehow force the server to reboot, and that's not really great. Unfortunately, it turns out that there are non-contrived examples of the same thing can happen. Next slide. So what if I have two data centers and they're distributed? So we do exactly the same crap. So instead of the reboot, what the attacker does is he just redirects the second message. He redirects one set of messages to server 1 and the next set of messages to server 2, and these guys have no joint state, and so you get back exactly the same behavior you had before. So this isn't contrived. This really could happen, and obviously one of the main applications for zero-round trip is people who have extremely high performance requirements. Those guys often have big data centers. They have distributed data centers, so we can't just brush it off either. Next slide. So that leaves us basically four options for our thinking. I mailed the list on this, and people should be familiar with this. Number one is just simply abandon zero-round trip. This superficially seems like you might think it was an attractive idea, but I'm going to argue it's actually not an attractive idea, and here's the reason. First of all, this is like an enormous performance gain to be able to do this in the on the first message. There are lots of cases where it turns out that these messages are safe because they're basically identified from the server's perspective, and we already know that there are application scenarios where people desperately want this and are going to get it somehow. And we need to provide this somehow, I believe. Second option is to keep state globally and temporally consistent across all time and space. That's probably possible in some application scenarios when you have like one machine and you have like pretend to be a different server identifier, but it's probably not like generally a solution. So this leaves us with I think two other possibilities, neither of which is like incredibly attractive, but both of which we can live with a big enough warning label. First option is and both of them involve relaxing one of the nominal guarantees which TLS has previously provided applications. The first is to remove your guarantee of anti-replay for that first message. That is to say that that first message we do not promise will only be delivered once. It will be delivered at least once. The other possibility is to remove the previous guarantee of reliable delivery and say it's delivered at most once. So this is specified knowledge, the only other two main options. I should mention, by the way, as I thought I mentioned earlier, as far as we know, this is an inherent problem. That is to say, it's not like this is some glitch in TLS that we just discovered and we can just steal something from some other application layer protocol. We don't know how to fix this. This is the best we know how to do.
Ecker,
yes.
clarifying question. When you say first flight in the third and fourth bullet, first flight of data or first flight just including the cryptography?
So, I mean, there's never been a guarantee to replay for the first flight of the cryptographic data.
Okay.
And in fact, that's why the client can't ordinarily send data until the third flight, precisely for that reason.
Okay, so you're talking first flight of client data.
Yes.
Thank you. Just want to double check that.
Yes.
But in 0RTT, it's the first one here
First
anyways.
flight client application data is the relevant thing. Yes.
Chris Newman, can we have advice in the document that
Yes,
TLS
so-
libraries have 0 round trip turned off by default?
I'm gonna actually propose something even more aggressive than that.
Okay.
Janai, just a couple of clarifying questions. When you say first flight, how does the application know what the first flight is going to be?
Good. I'm gonna get
Okay.
that.
So second clarifying question. I don't understand the last option that you presented. You said the at most one guarantee. How do you?
I think I can get to that too in a second. So, yes.
So Martin Thompson, I note that you can actually take those two options, the two remove options here, and allow the stack to provide this as,
Yes.
your choice.
Yes.
Pick one.
You-
I will replay it for you, or
Yes.
I will not
Right.
deliver this.
Exactly. So if you think, so maybe I'll take a step back. If you think about like a TCP stack, right? A TCP stack, you push data into the stack and it guarantees the data will be delivered, and it doesn't, and if it doesn't deliver, it tries to keep delivering it, right? And so we assume we want the same semantic here for this first flight, for this first flight of TLS application data, namely that, so ordinarily when TLS runs over TCP, right, TCP guarantees redelivery. But in the special case, can you just go back one slide? In the special case of 0RTT failure, the client explicitly redelivers it because the server says, I dropped this data on the floor. The server said, I rejected your data rather than it wasn't delivered. So that's what I mean by the reliability guarantee. Thank you, Jake.
Can you go back to that one? So your characterization of the fourth bullet there as we guarantee that it will be delivered at most once, I think is an inaccurate characterization of the proposal on the fourth bullet. What we're guaranteeing...
You're right.
Okay.
I agree. Okay. So what did you mean? I just wasn't thinking about it. We guarantee it will deliver some arbitrary number of times, and you don't know how many it's going to be, but it might be 0.
It's not at least once, and it's not at most once. The stack might report back to you that this message did not get delivered, when in fact the message could have been delivered.
Yes.
And now it's your turn to figure it out, what you want to do.
Yeah.
We don't know, the answer is we don't know whether it was delivered or not. But we're not going to replay it for you.
I'll have to think about this some more. I think you're right, but I'm not sure. But I'm not sure it matters for this purpose. Okay. Yeah. Okay. Next slide. So I think, as Chris said, I think we need to, not just a matter of defaults. We need to try a separate affordance for delivering this data, because delivered data is such a sharp tool. So we discussed a series of having a separate API for basically having just this data, and so if you're thinking about the semantic being, we'll keep trying to deliver it, but it may end up there more than once. You do something like this. You do the connection. You say set reliable, 0RTT data, and then you do connect, and the stack would just retry as many times as it thought was appropriate to make it happen.
So would you have an equivalent API on the server
Yeah,
side?
you would. You have a special way something special you had to do to suck out this data. I think that would be the appropriate thing. Yes. And I think So I think rather than having a configuration flag, I think this is so my argument for why I want a configuration flag is that the configuration flag will ultimately go fast flag and people will just flip it. Whereas this takes like extra effort to use, so at least the signal you really better know what you're doing. I joked at the interim that we should just put it in TLS.subtle, which is the web crypto way of apparently indicating that you should be really smart to use this API where all the API points are there.
Quick question. You limit this data then also to a small size?
I don't think we'd have to do that.
Because part of it can be on the 0RTT, and if you have a huge message, the other part would be delivered as part of the after the handshake, which you could guarantee something.
So I know. I think basically my assumption at least had been that. I mean, I think I wasn't. I mean, I don't think it has to be like fit in one TCP into one TCP MSS or anything like that.
So what is the guarantee about? I mean, the first part can be delivered, we don't know how often. Everything else would be delivered once, right? No?
No. It's still TCP.
So Martin Thompson, I think the answer here is that you put an arbitrary amount of information into this sort of replayable stuff, and it won't be until the time that you're just going to send all of it. You know, if this means that you've overflowed the TCP wind and you have to wait for round trips and all those sorts of other things to happen, you just keep sending it until you're done with it. It might mean that you actually receive the server hello and all the server's first flight before you finish sending this, but there's no requirement in TLS that we actually have the client's first flight complete before the server's first flight comes in, based on what I've seen of the design.
Yeah. And the server can distinguish these, and it's all.
It would only be limited by whatever limits we artificially.
Yeah, there's no. You have multiple records.
So if this is a handshake message, it'd be 2 to the 24 bytes, which is definitely going to overflow your C-wind.
Sir.
Ben Kadek, this is basically analogous to the GSS API case, where you can send per message tokens before your context is complete, and you can send as many as you want.
That's good to hear. So I think this would be one option. Next slide. And the second option I think would be basically we have no labor guarantees of any kind if the application's problem to figure it out. And then you have to have some switch statement where like the application goes, I'm told this wasn't delivered, I'm not sure what to do now. I don't actually feel I can live with either two API semantics. I think I'm done with this section, by the way. So yeah, let's now.
Adam Langley. I'd just like to express grumpiness about option 4 because applications are not going to test the very rare case where it doesn't happen and the attacker can trigger that at will.
That seems like a strong argument for option 3. My impression is DKG prefers option 3 as well. You don't want Garner's referring and doing
Stuart Cheshire, Apple. Yes, I agree, and I think we're all going to agree. Option 4 is dicey. IP can duplicate the packets anyway, so there's no way you can promise at most once. And when you punt this back to the application, then the application punts it back to the user, and the user's staring at the buy button, not knowing whether to click it again. So I think this is a dead end.
I do that all the time.
Yeah, hit the button.
I ate a lot of pizza.
Jana Iyengar, I just want to bring a data point which you know well, but I want to bring it to the conversation. TCP Fast Open has exactly this failure mode. Now, of course, there are different issues because it's not running on top of TLS, but one of the things that we did for TCP Fast Open was to identify in the document itself that this shouldn't really be used for non-idempotent requests. And that's something that an API user has to decide based on their use of TCP Fast Open. I'm sorry? The application, the user of the socket option has to determine if that's the appropriate option to use depending on the application that they have. Yes.
Don't sit down, Jana. So you and I were talking last night, but I just wanted to see if I could get you to replay what you said earlier about you having a lot of cases where you have data which is in fact idempotent and it's actually quite safe to do this kind of stuff. Did I mischaracterize what you said?
For TCP Fast Open, yeah. And the data that we consider idempotent is SSL handshake data.
Right. My memory when we discussed last night, you said you had like HTTP traffic also, where you were not concerned about replay of the client's message. Did I misunderstand?
Yeah, I think so. But I don't know. I mean, this is something that is an important question that we need to address, I think. I think that it'd be valuable to figure out how, I mean, the hard question here is going to be who gets to make this decision of what's idempotent. If you expose an API like this to the browser, does the browser look at a get and go, this is idempotent? Because sometimes there's server state that gets mangled that even the client might not know.
I just remembered another quick comment I had about the question about limiting the size of the initial data. I think it's a red herring because if you have a large semantic message, the client side receiving it is going to wait until it's got the whole message before it acts on that message. Yeah. And if the message is too big to fit in the initial window, whether you've got IW1 or 3 or 10, well, then it's going to take more than one round trip. So you've lost 0 RTT there, but that's because you had too much data to send. Right. But the end result is the application gets a semantic unit in its entirety, and they also don't have the anti-replay problem because it was too big to do a 0 RTT anyway.
So,
Chennai, you got again.
Hello.
Sandeep here. Clarification, is the sequence number in the replay, the message reset the same or it's incremented?
We haven't worked that out, but I would imagine they would definitely be distinguishable. They would use different cryptographic key materials. They'd be distinguishable. I think with it, I do not know. We haven't read through the sequence number yet.
Because if the sequence number is the same, then the server can reject the message, right? Second time.
I'm sorry, say again?
If the sequence number is the same, if the client sends the message again the same sequence number, the server could reject this message.
The problem, there absolutely will be some way for the server to distinguish 0 RTT data from replay 0 RTT data. I don't really figure out how to do it exactly.
Chennai, I'm sorry if to answer your question earlier about what I said last night, I think it's a really important use case to have 0 RTT. We do not want to lose 0 RTT is what I said, and I'll repeat that now on the mic, at the mic.
Pat McManus, yes, +1 on need 0 RTT. And then the question on, yes, it's get from a browser point of view, but is it idempotent or not? We already have to play that game in H1 and TLS 1.2 due to fins on gets that we have to decide whether or not to replay. So that's just an extension of that logic already done.
Just one other thing, when we look at like the API on the server side, just one thing we might want to consider is sometimes the SSL is terminated at a different place than where the HTTP runs.
We probably want to encourage people not to potentially not to use this feature unless they very much do what they were doing. I was thinking, yes, I mean, we're going to need some real caveats around that.
Yeah, I mean, I think what we're talking about, if we do incorporate this, there'll be a security consideration. There will be like security considerations with 0 RTT and make it very bold for everybody and for our ISG friends to be able to understand.
Okay, so you see I can summarize what I think I'm hearing, which is people would like to go for option number 3, which is the previous one, and yes, that I should attempt to start writing that up.
Yeah.
Of course.
Where? That one.
This one? Or, yeah.
This is not an option that was circulated on the list. I proposed that. What about a cookie-like mechanism? No, because the only real issue here, I mean, that's if you don't want to do it at API level. So the only real issue here, ignoring a server reboot forced by outside, the real issue here is replaying to another data center. Mm-hmm. So if there's some semantics by which you know that you are not supposed to receive that message, and therefore you're allowed to close the connection, that can be one solution to this problem.
Right. My sense is, I think this would. I think Adam raised this point at the interim. This would cause a high incidence of random failures on any kind of network topology shift.
I mean, I guess that's debatable about random failures. I guess we can think about it more, but the point is you should never receive that. And I'll draw an analogy with DTLS. It's basically, when you engage that, send me that cookie, and if you receive the cookie you're not expecting client to send, you're failing. So in a way, I would consider that's analogous to this case. You should never receive, let's say there's some sort of ID, identify the data center. you should never receive that ID at that data center because you established a relationship. The ID should have been different. It's identifier of your shared information.
So, Martin Thompson, absolutely not. The number of times that the clients are redirected to different clusters or different machines that don't have any relationship with the previous one, even within the same data center, is just far too high for this to be tolerable at all. There will be so many situations where you contact a server that just doesn't know anything about the key material, and if that produces a connection failure, this is just completely untenable, I think.
Also, it's worth thinking about what the client's response to this is going to be, which is going to be to reconnect.
Yes, I mean, so Adam Langley, there is fundamentally like a whole stack of replays here. Like either the TLS stack replays, and if it doesn't, like the network stack in the browser will probably like retry it. And if it doesn't, the JavaScript will probably retry it. And if all else fails, the user hits refresh. Right, so if you have a system which induces lots of random errors, then somewhere in this stack, it will just be replayed anyway.
So maybe we want to take a hum at this point. I think the first question will be on zero RTT itself. Do you support adding zero RTT? Do you not support it? And do you have enough information to make that decision at this time? So first question, hum if you support adding zero RTT to TLS 1.3. Next question, hum if you do not support adding zero RTT to TLS 1.3. Okay. And third question, how many people? Yeah.
If anybody that hummed for the last time, feel free to go to the microphone.
Let's finish. So how many people do not have enough information? Okay, some, but not as many as. So let's just hear from folks who either don't have enough information or who are against adding this feature.
Ron Schiffer, I think all the solutions on the table are not good. There's an old saying that you cannot make something foolproof because fools are so ingenious. So people will abuse this API even though it's so clear and so understandable and we know exactly what it means.
Rich Sauls, the objections have already been called out, so I would make the trade-off the other way, but I know which way the wind's blowing.
So, I mean, for the minutes, I would have to definitely say that there was definitely consensus to include it. So we'll obviously have to confirm that on the list.
Daniel Kahn-Gilmore. I also just want to point out that if we include this and we have all these caveats, and you're building a TLS stack and you think this is a terrible idea, you don't have to expose this to your users. If you're building for either clients or servers, and maybe we can encourage that kind of setup.
I mean, so I guess, Stephen, before you go, like, one of the things is we're going to document, like, you're not going to get replay, PFS, like, all that kind of stuff, right? So that we will stave off the what are you doing to this protocol.
Stephen Farrell. So I just have a small question. Has somebody looked at all of the other protocols that use TLS to see what the impact of this might be on them that are not HTTP?
Oh, no.
Okay. So, what's the right way? If the working group are deciding to include this, what's the right way to do that kind of due diligence, which I think we kind of have to do it.
I mean, my expectation would be to say that the applications specifically profile themselves to do this, or they shouldn't do it. So I think, the whole point of having this be a separate function is that you have to sign onto it, and I would say that applications should not use this unless specifically analyzed to profile to do it. So I want to put that back in the application office so they understand their
Chris Newman, I would actually encourage that we explicitly ask people in the apps area to write up advice on whether or not to use this for various applications. I think this needs to be a little more proactive. I like the idea of don't use it unless you understand it, but
Sounds like a perfectly good document for Utah.
yeah, and I'll help with email protocols.
Note that.
So if we're suggesting that there's some work here for somebody to do in Utah or somewhere, I'd like to find out if there's somebody willing to do that work.
Well, we got one. So.
Well, no, I mean, it's like the people in this room or the people on the TLS list are sort of causing work to be done elsewhere and saying, oh, please go do work. That doesn't usually work.
Stuart Cheshire. I understand why you use the GET example. The web is not the only application. At Apple, I know you know that, we have a bunch of applications other than the web browser and more in development where latency is really important.
Yes.
So we would really like this, and if not this, we'll probably come up with something worse.
I would be happy to work with. I'd be happy to work with you in the secret Apple layer to figure out which applications work well with this.
The App Cave. I'm actually really glad to hear that. Brian Sniffen from Akamai. I had assumed that this was intended for protocols other than conventional web use, video or chat or something, because I'm trying to imagine how to use this for HTTP, and I'm filling in that get slash with get favicon.ico, which is the most harmless possible HTTP request I can imagine. And then what comes next is a host header, and then what comes next is some cookie headers, and I can't figure out how to get all of it to where you actually get a performance benefit for rendering the favicon because you have zero RTT. That my guess, not well supported by experimentation yet, but my guess is that this is not going to provide significant performance benefits for first page latency. Maybe Adam's got better experiments than I do. So I'm hoping that this has lots of applications elsewhere because I don't think it's going to make a substantial difference in user experience for HTTPS.
Yeah. So Martin Thompson, I'm going to push back on what Stephen suggested there. We're not actually forcing anyone to do any work here. If they want to actually go ahead and use this stuff,
I think we're being directed.
We're being trolled. Is that what, are you using? Yeah. Well done. So is that right?
No. I mean, the idea that this is optional. I mean, it exists. It'll get used. It'll get abused. There's loads of context in which TLS is used. And it's only
you want to close them off.
I think we need to do some due diligence. We're adding a dangerous feature.
All right. Well, I will take the action to start trying to wrangle some cats to do this stuff, to communicate around with the other areas, with apps and other places that use TLS to see, what they would have to do with this.
So I was going to point out another application for this, which is WebRTC, where the number of round trips required to establish one of those sessions is already into the almost into double digits, basically. It's horrific. So what's one more is we're hoping to shake that down to basically 2 at most.
Adam Manley. So the first request to a web server is usually a get for slash, getting the index page. And zero RTT definitely does help. If you can get the index page and the sub resources it requires earlier, that's great. I don't know why you waste your first request on the favicon.
Ben Kadek, I know that applications that use TLS and applications that use GSS are sort of not going to be the same applications, but we do have some prior art here. GSS has this API to do this sort of unprotected zero RTT data, and we don't have as big of a disclaimer and warning on it as we should, but we can go and look and see what applications are actually using that. It's very easy. You can just go grab your source code, search your source code for GSSC prot ready flag, and if anybody's checking that, well,
I'll be in contact.
Ori Levin. First, I would like just to state the obvious. The more nice features you add to existing protocols, the less interoperability you get. I'm not against, I'm just stating the obvious. And the other commentary is that I think this due diligence about applications, potential use of this feature, I think the good place to discuss it would be on Utah. So Sean, we will talk about it. Thank you.
Janayang, I feel like I should come up here and do a Monty Python every RTT is sacred dance. But it is kind of, I mean, this is, if you want to bake in an RTT into the protocol, I'd strongly argue against it.
Okay.
I think are we closed on that? Are we closed on that topic?
I believe so. Yeah.
I sense we are.
Do you want to take any hum on the other options or no?
Well, I mean, so to be clear, are the chairs you should declare consensus on that previous thing?
Yes, I did. Yes.
Yeah, I mean, can we call consensus on option number 3? Which I think is the only one anybody's really excited about.
DKG. So Martin pointed out that we can define the protocol in such a way that either of these APIs are available. For the stack can choose between these APIs.
As far as I can tell,
I don't know that we care about that.
Well, as far as I can tell, as far as I can tell, the protocol, actually, I mean, yeah, we can certainly do that, right? Yeah, we can certainly do that. I mean, would people rather?
So this is more rope to hang people with, potentially. But I just observed that this one is a nice property for something that with string semantics like TLS, whereas the other one might be more appropriate for DTLS because, well, you lose a packet, what do you do? That was really the only observation that came out of that.
I mean, you're right, these are orthogonal questions, right? As long as you don't, yeah. Well, I don't feel like we have to decide this is an orthogonal question, like essentially everything aspect of protocol design. Like there was a single statement in, there was like when I've written this up, like one sentence that says, and then you must immediately replay the application data. So like what we're talking about is the existence or non-existence of that sentence. And so if people would like to wait on that topic, I'm fine with that. Or if people would like to leave it open, which is a big warning label, I'm fine with that too. My concern was to get people to get to the point where we agreed we're going to do this and we understood at least what the possible options for addressing this danger were. If people are comfortable with that, I'm comfortable with deferring this question for a little bit. Or not.
Why don't we just try a hum on option 3 and 4, if it's as two separate choices.
So option 3 is, how do we characterize that one? It's
Option 3 is we explicitly label this data as it'll be delivered, but we don't guarantee it won't be delivered lots of times. It's replayable data, correct?
Okay.
I'm looking for DKG to sign off on. But maybe you'd like to characterize these two.
So, well, I'm torn because the things that we're deciding between are not just the flow here, but also what's going on in. I mean, you get these labels here, right? I think the data is replayable in both cases. So when we say that option 4, we're calling it unreliable data. In fact, it's not only unreliable, it's also replayable. So if we have to choose between the names, then I definitely want the word replayable in there. More than I want the word idempotent or unreliable.
I actually want to go back to what you're saying earlier about delivery guarantees in the second option. So if the stack doesn't automatically retransmit.
Right. So one way to characterize these two is that in option 3, we're saying the TLS stack itself will retransmit the data for you.
I agree.
Right? And in option 4, the TLS stack will report to you whether, as you continue this session, we believe that this data was successfully received by the server or not.
Yes.
But we may be wrong. But we may be wrong.
Yes.
So is the difference from 1 to n times and 0 to n times? Yeah.
Although from the application's perspective, from the application's perspective, as I understand it, in the second option, it may have been delivered or it may not have been, but it was not delivered more than once. Because
and there's a distinction in terms of what state so let's assume that we end up with an established TLS session, right?
Yes.
In option 4, in the established TLS session, that we're working with actively now, the server does not have that data.
Yes.
It doesn't mean that the data wasn't played elsewhere against
Yes,
some other server or against the previous incarnation of this server before it died and came back to life or whatever. But in the TLS session that we're subsequently having, the remote server doesn't have that information in its data queue, right? So that's sort of the difference that we're talking about.
So we've been talking at N, but I'm not actually seeing how we get to N. I'm seeing how we get to...
There's three data centers across the globe, and I send a 0 RTT to one of them.
Yes.
And the attacker replays it to all three of them.
I understand, but two of them ought to try to force you back into a 1 RTT handshake. And so only one of them should accept it, and the other two should force you back into a 1 RTT handshake, and you only complete a connection with one of them.
And I reboot that other data center.
But wait, why are the other two data centers forcing you back to a 1 RTT handshake?
I'm assuming we still have an orbit.
I was
assuming we still have an orbit identifier.
Oh, okay.
But perhaps that's actually the relevant question: should we make any attempt whatsoever to do anti-replay here, or should we just abandon it entirely and have the guarantee and have an end guarantee? That seems like a real relevant technical question.
Yeah, I had not considered that there would still be an orbit value.
Well, it could go the other way. That would be tough.
Stuart Cheshire again. I want to thank you, Eka, for educating me about something here with your timeline diagrams, because one of the things that we've been looking at with some of the teams at Apple is to cut down latency, just bring up a connection in advance and keep the connection up 24 hours a day with keep alives, just so it's warm in case you need to use it. And I was thinking through the logic. I send a message over that warm connection, which has got wonderful anti-replay protection, right? I send a message, and it makes it to the server, but I never see the ACK.
Yeah.
And I send, and I resend, and I resend, and I time out, and what do I next? I make a new connection and resend the message. So keeping a connection warm does not give you protection if you respond to failures by making a new one. And of course, when you have a connection 24 hours a day, there are going to be NAT failures, firewall time failures, mobility. So you are going to have to make a new one, and that blows up this assumption.
So maybe let's take a step back for a second. Adam and I obviously are operating different assumptions.
Wait, if we have orbit values, then we're assuming the orbit sort of identifies the server cluster, right?
Yes.
But a server cluster will have many machines in it.
Yes.
So even with an orbit value, if there's no strike register, you can hit that cluster twice with the same 0 RTT handshake and get two different servers in the same cluster.
Yeah.
Yes.
So I've been assuming we're going to. I had in my head, I think that we're going to continue to use that replay mechanism, but that we wouldn't promise very much about it. But maybe that's the wrong answer. Maybe the answer is just to remove all the complexity and just say it's an infinite number of times.
But I think even with orbit values, it's still n.
Yeah, right. I'm assuming strike register as well.
Okay.
I'm wrong that
So I'm Debbie Kulina from NSA. I frankly think you label it as no replay, no anti-replay. Keep it as simple as possible.
That's what I'm coming to too.
Yeah. Why make it complex if you're not actually going to fix the damn problem?
I'm in favor of that at this point. I wasn't, but I am now.
So to be clear, in your mind 5 minutes ago, we still had strike registers.
Yes, now my mind we don't.
But now we don't. Okay.
And so now it's n.
So now it's n. So now the difference is between 1 to n and 0 to n.
So now I think I'm pretty sold on.
Chairs, at least 3 people in the room understand what this question is.
Okay.
Okay, so DKG again. So if we're going to talk about trying to have a hum between these two options, then I think the question that actually comes is, when the connection comes back, does the remote server have this data in its queue, or does it not, once we have a successfully established connection?
In the case where it did.
This is the distinction between option 3 and option 4, right?
In the case where you fall back.
In the case where you fall back, do we believe as a client that the server has this information in its queue or not?
And you believe accurately, by the way. That you can't be wrong about that, right?
Right.
Yeah, that's correct.
So is this worth doing a hum on now? Yeah, I think we're.
But I think I'll get with Adam and DKG and we'll try to write up a sharp description of what and figure out if there are any meaningful options other than the one and try to write up what they are and then try to get it through. And I think this is something that we do not need to nail down today.
Just to try to simplify things, I'm not hearing anyone arguing that we should pursue option 4. So perhaps that could be taken.
I think Martin was.
You are?
So very simply, if you're doing DTLS, option 4 makes a lot of sense.
All right. So you've got 3 of you are gonna get together.
Yeah,
get us something, and then do you want us to? We'll send it to the list and get people to do it, or you want to have a free-for-all discussion and then see what happens?
We'll figure out.
Okay.
Okay. So good. That was fun. This will be hopefully a lot more fun. As we all know, TLS has gone through evolutions. Original TLS basically was like RSA transport. You could try to do PFS, but nobody really wanted to because it was slow. And now we sort of moved towards doing a lot more PFS. And 1.3 only allows for at least the public key systems only allows for DHE and ECDHE to have a PFS based system. The present draft. Next slide. So the present draft has the same protocol logic for Diffie-Hellman as 1.2 did. Namely, it's a signature-based scheme where the server signs his Diffie-Hellman ephemeral share, and the client verifies the signature and then uses the Diffie-Hellman share. And we've done some rearrangement, so it's a little different than 1.2 because now the share comes outside. Now we start encrypting as soon as the share is delivered, but then we sign later, and we sign and as part of that process, we sign the entire transcript at that point as opposed to only signing a single message. The logic is a little more straightforward, perhaps, but it's the same basic underlying protocol logic. This is how we handle 1RTT. Unfortunately, it should be clear as I mentioned earlier, it doesn't work for 0RTT because there's no place for the signature to go because the client has to know the server's key in advance. About back to the Paris syndrome, Hugo pointed out that if we were to do a system based on a statically certified Diffie-Hellman server key, then we could unify the protocol logic of both 0 and 1RTTs because basically in the 0RTT case you would assume that the client renews the server's key and think of it almost as soft state, whereas in the 1RTT case the client server delivers it in the first flight. This is the same protocol logic that Chris uses as well, by and large. We had a lot of discussion about that, both in the Paris room and then the Honolulu room and then the Honolulu meeting, and there was some resistance to this design. Largely, I think, because people weren't sad about offline signing of that value, and about sort of the I want to say the I guess called a one-time attack, the sort of leakage of security outside the server's nominal security guarantees. So to give you one example, say you have a cryptographic token like an NSS, where you have a signing where you have where the signing key is in this token, and so you can't extract the signing key. You can just make as many signatures as you want if you control the server. So in the case we have offline signing signed by the server's key, then I can translate temporary access to the server into permanent access by just signing myself one This is not time to relitigate this point. I'm just reminding people that this doesn't apply, by the way, to David Hellman Surf. We don't really have that right now. We also explored the same protocol logic with an online signing option. And at the time we looked at it, it had negative performance consequences, which we think we've now resolved in the discussions. Yeah. Again, just sort of recap. So next slide. I wish I'd shown you this slide earlier. The idea here is to have an ultimately home protocol logic, and try to unify, I say, both one RTT, cached 0 RTT, where the client says, look, I already know your keys, so I'm not sending you any crap, and 0 RTT, and also as a bonus, unifying the PSK cipher modes as well, where you think of the PSK as the same as the combination of the client's ephemeral and the server static, just like the authentication that you do for the 0 RTT part here. Obviously, the PSK no DPO modes are a little lucky, but we make them. Next slide.
So I guess the only thing I want to add on that is that the reason why you would make it uniform is so it makes it easier for people to study it, so that we have more buy-in from cryptographers and the like, because we've been harangued for.
This was a request. The request to have as few protocols as possible has come from a very large number of sources, including the analytic community.
And including people who have to implement these wonderful state machines that we've come up with that do all these marvelous things.
Right. Next slide. Right. So basic idea is just like in I should say 0 RTT on the first slide. The server has a semi-static DPO key, just like in 0 RTT, and he authenticates that with this long-term signing key. But these key computations are exactly the same. So what does this diagram look like? Next slide. So there's actually a pull request for this, by the way, a draft version was to the list, so people had a chance to read this in advance. But basically, the major rearrangement here is that previously we had a certificate verify signing this entire transcript. Now we have basically the server's long-term semi-static DPO key in the server parameters block signed by the server's long-term key. Next slide. So I hacked up something just so we have it in our heads. You want to have some not before, not after blocks that tells you how long you can use it for 0 RTT and for caching, identifiers so you can refer to it, and then the rest of this stuff is just the same stuff as before, namely the group identifier and the server key itself. And then you sign the whole thing with plus some context data from the handshake with the server's key. So what context data should be? Right now, I'm just having this be as a session hash, which is basically just a transcript again. So if you think, so one way to think about this, but there's two ways to think about this, right? One way to think about this is a online signature bound to the handshake, and if you just had like this value be 0, then offline signature not bound to the handshake. The other way to think about this is actually almost identical to the previous thing, just with the key, just with a separate key, right? Because you're still signing the entire transcript in the online case. So hopefully it makes it easier for you to reason about the security of it. Next slide. Right. So as I said, there was reference does not to offline signing, so we need some kind of online signing. We need to tie it to the handshake. The minimum thing we need, as you guys pointed out, is just a client random. But since we have the server session hash flowing around, it seems harmless to hide the second hash, and that's what we're going to do other things as well. So if you wanted to argue for the same thing less than session hash, you can do that later. That's a good flag. My argument would be for it would be false suspenders. Maybe starting for now.
So Adam Langley. So one point is that we're doing this online signing so that people with HSMs can sort of recover from a point-in-time compromise, but they still have to be aware that they may have leaked sort of 0 RTT state to clients, and therefore the attacker may be able to come back in the future and decrypt that 0RTT message,
Yes, quite
which
so.
may include cookies.
Quite so.
So they're not completely out of the woods, and we shouldn't
Quite so.
suggest them.
And also, of course, they may have leaked their, yes, quite so. And also, given that, given the state of HTTP typically, they probably have, presently the 0RTT key is probably floating around in memory somewhere. Okay, next slide. So this gives you a diagram, so actually, you guys have a diagram, which is something that I'm not trying to incorporate. But this gives you basically a unified key duration diagram for both for essentially every protocol mode. And this one's kind of ugly, so I'm actually going to just skip past it. So this is in the draft. So the final relevant factor I want to bring out here is performance issue. So the offline side version of this. So there's a lot of confusion here because we are operating with radically disparate performance properties for different primitives. So you can have finite book to be Hellman, or you can have EC to be Hellman, you can have RSA signatures, or you can have ECDSA signatures, and all these are radically different performance properties. And so the exact performance profile you get depends on which things you're operating under. So in particular, the two most interesting cases, which are the case where you have an RSA certificate and your ECDSA certificate. So if you have a RSA certificate and you have ECDHE, which is almost certainly what you want to be using, then this is essentially identical performance properties to the existing handshake because it has twice as many EC operations, and once we do an optimization, I'll talk about in a second. But the RSA sort of says that basically nothing else matters. It's not quite true for the server, for the client side, the server that's the big issue. If you have, however, if you're having ECDSA signing, then so by the way, this is the first one. I should explain. These VB means variable based exponentiation, which is the fixed operation you use in both client code and ECD. So in the online signing case, where you have an EC signature, then the naive version of this is substantially slower, 50% slower, but it requires a signature plus a whole second set of different operations. The offline signing case, just for reference, is roughly the same cost as the current thing in the EC case, but not quite as good because EC signing is somewhat faster than EC. But obviously, we heard you last time we discussed this. We heard you when people said they were sad about extra so Hugo and Hotek and I sort of sat down trying to figure out how to get rid of it. And so it turns out that the hack lets you have to read extra Hellman with retain the same protocol level. And the basic idea here is, can you scroll back to the diagram? That one. Yes, good. There are two Hellman keys being used, one here and one here, right? And this is nominally the ephemeral one, this is nominally the long one, right? However, if all you're doing is a 1 RTT handshake, and no one can ever do 0 RTT, then you didn't actually get any security benefit from having this value be long and this value be short, because you don't have to reuse this key anyway, and so you might as well do a fresh one. And so the next observation you can make is you can just make these keys the same. And if you do that, then again you have the same protocol logic, but now the server can simply only compute the Hellman once, and just then copy the result into the slot in the key derivation diagram. And the client can, if you choose it, the client can. So there are two ways the client. If the server knows what he's doing, the client may or may not know. There are two ways to deal with this. One is to have a protocol indicator that says I use the same value here, and the other is to just send the value twice and let the client figure it out by doing memconf or not as he chooses. Based on I hate conditions, so my vote was to put the value in the protocol twice on the client. Sorry, we can talk to that point later. If you do that, can you scroll back there? If you do that, you end up in this case, and basically now it is exactly the same for characteristics. Modulo on memcopy, which I think we can stipulate this very fast.
So, Martin Thompson, I don't know if you're getting to this, but the observation there is that you can't use the static one in the static use cases if you make them the same.
I'm going to get there in a second. So this covers the 1RT use case and gives us the same. The best performance properties we know how to get, unless we're going to do HMQB, and still lets us retain the same logic. The point Martin was just raised is this doesn't work if however you want to implant a key for 0RTT, you can't reuse the same key in both slots because the key can't be simultaneously short-term or long-term. Next slide. Right. I'm just going to start doing these. In the design I just showed you, this gives the server an annoying trade-off, right? The server can either choose to be like, I want to do 0RTT, and so I'm going to chew up an extra Diffie-Hellman computation now in service of the future, or I don't want to do 0RTT, in which case it's faster, right? So the other option is to simply have two slots, one of which is this is the key for now, and one of which is the key for later. And that, of course, is protocol complexity and some other crap, and that's annoying too. This is but now you see the entire landscape of what the options are making this work. Effectively, I mean, the top of this. I mean, you have to look at the Lisa decision tree, but the top of the decision tree is do we want to make this change, which I think there was a fair amount of support for in the interim, but I know people wanted to see written up, which is why we're having this discussion now. This change overall to a Diffie-Hellman structured logic, and then the second order question is like, how do we handle this issue here? So I think that's enough introduction. I'm hoping we can discuss this.
People need to get up. Adam Langley, yes, we should do the Diffie-Hellman logic. No one should be surprised by that.
Yes, I must like that. What do you? Yeah. Oh, I'm sorry. But let me just say one more thing before I forget. Is that if we do the one advantage I perhaps mentioned of doing this Diffie-Hellman logic is if we later decide we want to do offline signatures or Diffie-Hellman certificates exist, then this is a trivial set of changes to enable that. Whereas if with the present logic, effectively these are entirely new sectors. Sorry.
It was okay. Jim Schott. So if we actually do the first option up there, in point of fact, before we get to the point where we are producing two keys, both the client and the server have had to say that, yes, we are potentially going to want to do a 0RTT in the future, correct? Because the client had to ask for it, and the server has to agree to do it.
So I think not quite. The server can always, can you scroll back to the parameter clause? Yeah.
Nope, next
Sorry,
one.
no, that one.
Next one.
So the server can, my intention here was if you put zeros in these values, you never reuse. And so the server can, without knowing what the client's capabilities are, the server can decide either to provide them with a complete ephemeral key and mark it not for reuse, or provide them with a static key and mark it not for reuse or for reuse. But now it would be nice if the server knew what the client's capabilities were, because there's no notion of ever doing 0RTT, then the server shouldn't absorb the computational cost. But even without the client indicating that, this would still work.
Right, but what I'm saying is you're not going to end up paying the, if you know both that the client wants to do 0RTT and you're going to do 0 to RTT, then absorbing the cost of doing that extra key computation is not as bad if you do it up front.
I agree. So I think that if we, my assumption has always been that we have some indicator of I was like a 0RTT friendly person. And I think in this case, I think if we were to take the option of you had to decide had to pay the price there, that we would definitely have to have an indicator set up as a zero-key friendly first.
Andrei Jivsov. Just thinking about complexity, if we were to start with assumptions that we know, which is online signatures, it seems like if you just do basic Diffie-Hellman for PFS, and you do online signature for that, and then you include the semi-static share there, it seems to simplify a lot of things. It definitely achieves the top performance that we have right now, especially going forward with ECDSA, ECC everywhere, right? And I mean, it just works, and you don't have this compromise. And then your shared secret is PFS based. You do it in zero RTT case, and you do it here as well. So KDF works in a similar way. I guess, you know, one needs to justify, you know, given where we are right now, if this actually is simpler than a basic alternative.
So let me see if I can restate what I thought you said, which I don't entirely disagree with, which is that if we just retain the existing 1.3 protocol logic and then just have a slot to shove this guy in as a zero RTT primer, then
some extension or whatever.
Yeah. So in fact, I have a write-up of exactly that. And I agree that it is simpler in some ways. It's simpler in some ways and more complicated in others. It's more there's more sort of knobs and twiddles in the key generation diagram, and I'm told by the photographers more knobs and twiddles in the analysis, but I'm not prepared to talk to that.
Because you know that the zero RTT becomes pretty much the simpler case of one RTT where you don't have a signature, because you essentially have well, you can say static Diffie-Hellman key. And then, well, PSK is there, but it's unclear how it fits anyway. But I think it bootstraps the same way. So in all these cases, you have the same shared secret, or, you know, input secret that, you know, you have in the draft, and you just bootstrap from there and go with KDFs down.
Ugo Kravchik. Basically, I mean, what you're proposing to keep the TLS signature and add this static or semi-static key into the signature is essentially what the G to the Y equals G to the S is doing. It's exactly that, except that it is structured in a way that now we can analyze the whole protocol on the basis of a static Diffie-Hellman. I'm not having to analyze a separate mode, which has a different logic. I mean, it's kind of, at the end of the day, is structuring the protocol and the analysis in a particular way, but the end result is, you know, if we wouldn't have all this discussion, and I would show you just the end protocol, then you see that there is no much difference. Or basically not any fundamental difference.
Well, we ended up with a situation where we're going to mem copy S in a semi-static into a femoral. And so I think that complicates. I mean, you have a different proof, right? You got to have a different proof because now it's in a way a completely different mode. Well, because, right, if we want to maintain a performance without degradation, right, we copy the shared key into a femoral. Right? I mean, it seems like a server that cares about performance will have to do that. So you essentially don't really have a static component. Like, you know, I appreciate that idea of integration, but, you know, if you care about performance, and let's say don't care about zero RTT, because actually right now is a compromise, then I think that affects the proof.
The G to the S equals G to the Y is a trick that, to simplify specification, if I was writing the cryptographic protocol, I wouldn't even mention that equal thing. What I would do is I have only G to the S. I will prove the protocol without forward secrecy, which is something that we have done already. I mean, previously has been done. And now I'll say, okay, this doesn't have forward secrecy. Now, this is a static Diffie element, so it doesn't have forward secrecy. Okay, now let's change that semi-static key every session. Okay, we didn't change the protocol at all, but because we changed it every session, we got forward secrecy. So from the point of view of cryptography, it doesn't exist. Now, these people that do implementations and specifications, they like to do it that way. It doesn't change anything on the logic of the protocol. And if you want to do it differently, you can do it differently. That definitely is not me to say how to specify the things. But the logic is that one. And I can show you. You want me to show my two slides?
Yeah.
Up to you.
Where are the two slides?
Are they in here?
Right here.
Are they in this?
I know, I emailed them to you separately.
So I prepared the two slides basically last night, trying to summarize responses that I gave over questions that were raised on the list. Basically, I would call these two slides demystifying OptLS, because if you see all this discussion going on, you can think that there is something very complex, or who knows, some new cryptography being invented, and there is nothing like that. I'm not saying that because we are using previously existing mechanism, you shouldn't be analyzing this protocol. We should be doing that. We are doing that. But I just want to show that really things are simpler than they may look. And also to translate the ASCII presentation into something that shows that there is some math, or the X instead of the...
Is this the right one?
Yeah. So one of the questions that people ask is why all of this? Why changing the protocol? What's new? And there's some very significant things that are new. I guess most of what I'm saying is just repeating a thing that Eric said. So what is new to TLS 1.3? Now we have forward secrecy as a mandatory requirement. We have zero RTT as a requirement. And there is this thing that is not a requirement, but actually have to keep in mind that now we think of the protocol being implemented with elliptic curves. So these three requirements basically call for three items here. Diffie-Hellman as the essential primitive, because it gives you forward secrecy, and it's basically the only implementation that we have for using elliptic curves. Then we must have a server static Diffie-Hellman key in order to support zero RTT, because you have to encrypt the first flow, and the only way of transmitting that first flow is with an encryption mechanism, and there is no encryption using signatures, so basically signatures are useless for zero RTT. Signatures are only good in an interactive protocol, and here you have one-shot message that you need to encrypt. So no question, no other way. Okay, so there is no options here than having a static key for the server. And the last one is that for zero RTT, we need to support caching of the static Diffie-Hellman key by the client, and so we have to do that. And if we can support caching, we actually have optimizations for other modes of the protocol. So these are the three things that change. These are the three elements that follow from these things. And the observation, or the basic generating idea here, is that instead of having these old protocol and new functionality or modes being the union of two different protocols, we can unify them at very little cost in the sense of specification, but which gives us a single logic that we can analyze. You know, I'll show in the next slide the protocol and some of the possible modes that it has, but the nice thing is that everything comes out of the same logic, the same analysis. So Yeah, so we unify the regular one RTT, the zero RTT, and caching, and also and whatever was there before the signature-based authentication. So the idea is basically the server signs. So now everything is based on a static key, but we don't have, we are not assuming Diffie-Hellman certificates, so we don't have a certified static key. We are not assuming offline signatures, so we must sign the static key during the one RTT. So the server signs the static key, then it uses it for session authentication, for caching, and zero RTT. So it covers all the functionalities with that static key. And we get a uniform logic, but also uniform specification. So it's not that we are sacrificing complexity of the protocol or its specification because we want to do something which is elegant from the cryptographic point of view, but actually these two things go together. I mean, a simpler analysis, unified logic means also a simpler specification. So also the key derivation gets unified, and this is not only applies to the static Diffie-Hellman or signature-based modes, also for the PSK, the pre-short key, gets basically the same.
Next one.
Okay, so look at the first three bullets. That's the whole protocol. Okay, we are talking about that. The blue part is what will always be performed, and the black additions in the square brackets is the optional elements. So forget the black for a moment. So all we have is everything that you know from previous TLS, client hello. Oh, okay, sorry, not from previous. I mean, it's the previous TLS plus a Diffie-Hellman exchange for forward secrecy. So you have a client hello with a client key short G to the X, the server response server hello, ephemeral G to the Y, and the finish message, which is a pseudo-random function computed under G to the X XS, where G to the S is the static key that has been cached by the client. Sorry. Rewind. G to the XS, it combines the ephemeral of the client with the static of the server, and all of that is applied to the session hash. So you are authenticating the whole exchange with under a key derived from G to the XS. And then we have a finish from the client, which just serves as explicit, key confirmation, just to know that the client computed the key. So this is the basic thing, and except for the forward secrecy, the rest is the elements that were there before. Now, what are these two optional elements? So in the first one is the client early data. If the client wants to transmit data in the first flow, then it will just take G to the XS. I mean, he has G to the X, he has G to the S from the server, computes G to the XS, and encrypts with that the early data. Okay? So that is the zero RTT. If a flow that supports that will get that. The second optional element here is this thing that they call the server static key envelope. Actually, it's called security parameters in Eric's draft. So what is in that envelope? It's a static key, G to the S, the signing certificate of the server, and a signature on G to the S and the session hash. So in the original OpTLS, I was thinking about these things as an offline signature. Now it's the same logic, but with an online signature, the client knows that actually that signature has been produced freshly now. So these are all the elements in the protocol. And this gives you a flexibility of choosing different modes of the protocol. That doesn't mean that you have to support all of them, but the protocol logic provides you these options. And so let me go over that. So there is the first one, which I call the cached one RTT, which is one RTT where the client had a cached key from before. And basically, that protocol is only the blue part. Okay, that's the basic protocol, no additions. It assumes that C had G to the S cache from before, but it's not sending data on the first flow. I mean, nothing else changes in the protocol, it's just the decision to send or not to send data. Okay?
Okay.
Now, the complexity, the performance here, you have no signatures, and you do two exponentiations. You have to compute G to the XS for the authentication, and you have to compute G to the XY for forward secrecy. And a bonus of this type of design is that now you can derive keys, the application keys, from both G to the XY and G to the XS, which gives you security in the case that ephemeral values are revealed or the static key are revealed. Of course, if both Y and S are revealed, then nothing is secure, but if one of them is revealed, then you still have security.
Yeah, so Martin, Tom, just a clarification here. The point here is that the client remembers the binding between G to the S and the identity that it has from some previous association with the server. So it doesn't have to receive a signature in that case because it has remembered this association from the past. That's essentially what you're relying on. So it's more than just cached G to the S, it's cached G to the S and this additional binding information that we've seen previously.
Mm-hmm. Yep. So then we have the same mode, but in the case of zero RTT, the only difference is that the client is sending data in the first flow, same complexity. Then we have what I call the transport 1 RTT, which is a case where the client did not have a cached key, so the server transmits the static or semi-static key to the client. So what it does is actually sends this SKE envelope with a new G to the S and a fresh online signature on G to the S. In this case, is the one amortized and two exponentiations. By the way, the exponentiations here are variable-based exponentiations. All of them have one fixed base exponentiation, which is cheap, but anyway, it's common to all the modes. And the last one,
which is not on. Can we get the plug-in? Sorry about this, guys.
So, well, the last one is the one with the where G to the Y equals. Yeah. So the last one, as you see, I'm not saying that it's G to the S equals G to the Y. Only I'm saying is G to the S is ephemeral. The G to the S equals G to the Y is just a trick to maybe simplify the specification, but there is nothing other than being G to the S ephemeral that gives you both the authentication as in all other modes plus forward secrecy. And the good thing about that mode is that it costs just one signature and one exponentiation, which is the same thing as what the naive signature mode would have given you. And in all the modes, we derive keys from G to the XY and G to the XS, except for the last mode, in which we don't have, we don't have a semi-static S, we only have an ephemeral one, so in some sense you get some security penalty by doing that mode. Basically you go back to what you would have had if you used the naive signature mode. So these two modes that actually have signatures have different types of trade-off, performance trade-off. For example, this one is great for RSA, if your signing certificate is RSA, because it means that you do one signature, but that signature signs something that allows you to run protocol without any signature as long as the client caches the key. So that while the second one, the ephemeral one RTT, is better for the ECDSA because in ECDSA signatures are cheap. So again, I'm not saying that you have to support all of these modes. I'm saying that one logic supports all of them, and I'm not showing here the pre-short key, but pre-short key is exactly the same, where you replace G to the XS by the pre-short key, and everything else stays exactly the same. So that's it.
Adam Mangley. So, Eka, you're not actually proposing to use all of these modes, right? Like, for example, from what I understood of what you were saying, there would always be a signature in the handshake. So, like, the cached 1RTT wouldn't be one of them.
I'm not sure what I'm proposing.
Okay.
So when I wrote up the protocol machinery we need to have a discussion about what the protocol machinery is for indicating what the hell is going on here, right? And I think we have to decide whether. And so obviously the protocol machinery for saying there's a 0RTT protocol machinery, and so I think the question is, should there be an intermediate protocol machinery for saying I know your key, but I want to do 1RTT.
But so there's also, the second mode here, the cache 0RTT, from what I understood of what you were proposing, is that there would be a signature in that mode. Sure, the 0RTT data is purely protected by like the client's cached information, but when the server comes back with its flow, it's always going to give you a fresh signature over something, whereas here, like that second mode has no signature. Are you suggesting that we...
I've gone back and forth from that.
Okay.
I'd love to get people's input on to discuss that actually.
I mean, so Quick obviously amortizes and caches signatures all over the place.
Right, yeah.
So my thinking of that, which was 2 years ago, was that actually RSA is often quicker than ECDSA holistically. So if you are a server, and the RSA signature is obviously very slow, but the RSA verify is really fast.
Yeah.
Your mobile client is fantastically slow compared to your server.
Yeah.
So that, right, the sum total time, RSA is faster. So that's why I wanted to sort of amortize the RSA signatures on the server and then use RSA where possible because the clients are way happier.
Yeah.
So that suggests that, being able to not have these signatures would be a plus.
And that was the reasoning by which when I wrote this up, I had that in there.
Right.
But on the other hand, it's more complexity, so it's like, yeah.
Okay.
I'm sensitive to this issue. I think we're going to need more discussion on what exactly the possible flows are there, or offline.
Yeah. So Martin Thompson, I think the key here is whether or not we require the signature on every single handshake or not. I think that once you have this concept of hooking all of your authentication off G to the S, then when you do the 0RTT thing, there's no real distinction between that and the 1RTT case with a cached G to the S, because essentially you just send 0RTT with a 0-size payload. I mean, I'm in two minds about this as well, given the ability to amortize the signature, but then on the flip side, that's a lot of extra optionality in the protocols. I could go either way.
Hannes, so I actually like a little bit of that optionality because obviously people have different focus on different performance optimization. Adam probably cares more about the web server performance, and some people care more about RSA than ECC. So in my use cases, I care more about what the client does and specifically what happens with ECC. So I don't care whether the server has to do a signature operation more or less.
It's worth noting that to some extent the question of which modes you support here is an orthogonal question to the question of whether we should make this general adaptation, which I think we're still discussing, right? Though obviously, as I said before, because these modes these are the decision tree, we have to add them up to determine whether we like the intermediate nodes.
So Adam Langley, if we supported the additional complexity of the client remembering GTS, perhaps then we could jettison resumption. That's obviously the trade-off I made in quick.
Right. So yeah. So my understanding from talking to a number of the server vendors, although not Google server vendors, obviously, was that they felt like they wanted at least one all symmetric mode, including resumption. That even the cost of the EC was too high.
Okay.
I invite them to say that now, or contradict me now. I mean, Rich, Brian.
That obviously has impacts to the level of forward security we can provide.
Yes, I agree. Brian, Rich, anybody else? Huh? Do you want to speak for resumption? He's not moving. I kind of am quoting you, so you know.
I'll speak against it. If you are a large server operator, your CPU time is pretty much dominated by shitty clients that make hundreds of connections and don't do resumption and just slam you with RSA signatures all the time. And you kind of have to support them, and they're usually like robot API clients. And they are such a huge chunk of your time that the well-behaved clients that can do resumption in the browsers are kind of like, yeah, whatever. So whether they can do like an all-symmetric or whether they need a couple of ECC operations is not a huge deal. And you get real forward security.
Rich Saul Akamai. Yeah, it's not going to be a big deal, because what we're actually going to have to do is provide a knob that lets us choose it for customer. You know.
So I guess you'd be happy with losing resumption? Because I've been assuming we had to keep resumption, because we talked about this like a while ago, and there was like people said don't get rid of resumption, and I'm happy to open that can, but let's I don't want to open it up by accident.
Yeah. So it's not that we're losing resumption; it's that one, we've got air cover because it's not our decision; it's the IETFs and what the browsers do. And so,
Thank you for being honest.
Two, if you want sessions and resumption, you know where TLS 1.2 is. So.
Well, that would make me very sad if people still fight the lot of need for resumption. And the other thing that's worth mentioning is that resumption does two things, right? It also provides continuity of authentication and stuff like that. If people seem they want that. Andre? Sorry, I'm flying through the microphone here. I really don't want to just accidentally make this decision.
So Andrei Popov, Microsoft. From my perspective, resumption is only possible in our data centers right now in a very limited set of cases, because we don't do key sharing for session ticket stuff right now. We've added support for that, but it will take a while to even roll into Azure and such. So in theory, if we lost resumption, the state change from the current state to the new state would not be that big, I would argue. Although again, I'm not running Azure, so I can only speak for the TLS stack itself.
Hannes, so I guess you know my answer already. So I don't like that idea at all to ask the session resumption, because it's performance-wise, it's a massive win. So I guess I care for the IoT use case. The resumption gives us a tremendous performance difference.
Brian, Stefan, when Rich said there will be a knob per customer, what he meant was that folks who want to do a lot of static content will stick with TLS 1.2 because that will be the fast protocol for idempotent things. And so if you're going to take out resumption, you might as well go whole hog with zero RTT weirdness, or take it out on the third hand, because it will fork a world into. I worry that it will fork a world. I can't see the future any more than you can, but I worry that it will fork a world into people who want to stay on TLS 1.2 because they want low latency social media profile pictures.
That's really a deal breaker for me if that's going to happen.
So this is Deb Cooley again from NSA. So I want to ask you some stupid questions. Of this, where do you lose PFS?
So my understanding is that all of these have PFS except for the first flight on the zero RTTs.
So just the beginning of the second one.
Yeah,
Okay.
that's my understanding.
So, yeah.
That's right.
So when you cache, server credentials. You also have to cache, keep, whatever you want to call that. You have to keep the identity. It's not, as Martin says, not just the credential, it's the identity that you've bound to it,
Yeah,
correct?
that's my
So you're
understanding.
going to trust the client to keep that.
I agree with that.
They are doing the trusting, but sometimes clients aren't whole, right? So what's the chance that you're going to have somebody in the client that doesn't want that kept? How much can you I know the client's keeping, the client has to trust it, but can you always trust that a client is unsullied?
I'm not sure I can answer that.
I know.
So right now, you already have to trust the client is unsullied because we have resumption. If the client's resumption cache is in any way compromised or so on and so forth, you can already impersonate. Yeah, if you're worried with this, you should be worried now.
Okay, that's all my stupid questions for now.
Those are good questions.
Okay, with regard to resumption, this is Joe Salomon. One area where we used resumption a lot is with ETLS, which is kind of a different use case, but it's so authentication and handshake bound that the resumption and stateless resumption were pretty important. So,
my hope, by the way, for how to simplify resumption is to turn it into PSK. Was the discussed plan for this. I'm not totally sure it's going to work yet, but.
So Martin challenged me to expand on why we care about resumption a little bit in a sidebar. And one answer is really dumb clients on really good networks where the CPU cost is relevant given the extra latency, the extra network latency, and so dominates in the total latency. But the second reason is during a denial of service attack, it means we can continue to serve people who can resume without having to do expensive asymmetric crypto for them. Whereas people who are showing up for a new negotiation, well, they go to the back of the line, maybe they get through, maybe they don't. But the DOS bots take a while to get through, and the legit clients get through. So it's mostly about that case of continuing service during a sudden load event, whether that's a new product announcement keynote or a malicious attack.
So I was going to say something different, but in response to the previous speaker, yes, there's this use case where there's a denial of service attack going on, and detecting the possibility of resumption is one of the ways to keep the ongoing connections flowing. So that's kind of, or previous connection continued. So that's actually a valid point that is being used in the data center. I know about that use case. Then the other thing, though, I was going to say, which is kind of leaning the other way, is that if we're saying that TLS 1.3 is PFS only, then resumption kind of conflicts with that goal. And I never thought, for instance, that session ticket-based resumption provides PFS. Not my definition of PFS anyway.
No, I agree. I agree it does not. That's one of the reasons why we split up the key, so at least the resumption wasn't a threat too. So I was going to suggest that we maybe, I was just probing for whether there's consensus on this, but I'm not sensing consensus, so I'm wondering if we should table the resumption question.
So people like resumption, but if we're happy with getting rid of forward secrecy with resumption, then perhaps rather than having resumption be a PSK here, the client can simply choose the same ephemeral, in quotes, key, and the server can say, here's the shared key encrypted under symmetric key I already know. And so therefore resumption just fits into this.
Right, so I think, right, so you're saying that the server, say that again, maybe.
I'm saying that we turn resumption into caching the Diffie-Hellman operation.
Right, so the server sends you effectively a ticket that contains inside it the Diffie-Hellman, the public Diffie-Hellman shares that it's supposed to correspond to and the outcome of the computation.
Yes, and the client does resumption by sending the same, in quotes, ephemeral key.
That's a good idea.
Just a thought.
Hannes, I personally don't like to see the resumption as not providing BFS because with the previous exchange you had BFS. It's just not with every exchange, and I think that's it sounds, in the way you phrase it, it sounds a little bit more radical than it actually is.
So yes, sorry, let me, so the P in PFS is very absolute and completely inaccurate, right? It's, your FS is bounded by sort of a time window. And so people generally use the P to mean the time window is the current connection. But whereas in current TLS we have resumption, so that's nonsense. The time window is in fact maybe the time length of like the session caches at both sides or the time length of the ticket key, right? So it's much more amorphous. So I get having PFS with the time length of the connection is sort of an easy conceptual thing, and which people generally call PFS, which we could get if we always had asymmetric operations. But if we're willing to stretch that time, then like it's not like the P suddenly disappears. It's not a hard.
Right, and like the general definition of BSS, a perfect forward secrecy doesn't obviously take some of these more complicated lifetimes of DLS into account. So I think, and I don't think there's a pre-agreed notion on what it actually means in the DLS exchange either. I think it's for us to decide to come up with what properties we would like to have. There's not something cast in stone already. And I think, and my notion is you can use BFS for that initial exchange, and then you can resume it up to a certain point, and then you do the BFS again. It doesn't, because I see that being useful in a number of scenarios, like the IoT cases I mentioned earlier, and there you may not need sort of the Diffie-Hellman exchange with every exchange.
So yes, so we have the case at the moment where sort of in theory, or at least in PR, TLS has forward secrecy. But in practice, everyone is keeping their ticket keys on disk and their session cache on disk, and you can't actually tell as a client whether the server has completely fucked it up, and most servers probably have.
Closing the line.
Right. I'll speak quickly. There was a possibility here that we simplify things and we get a really hard FS that everyone can be sure about. But it sounds like if we need resumption, and we probably do, then we can't get that, but we're no worse than we are today.
Yes, so Martin Thompson, I kind of like the suggestion that Adam made there with respect to copying the keys around and simply making some sort of commitment on the part of on the clients, some sort of rule that says clients just use the same ephemeral, and you can resume that session, or essentially just create a new one that looks to the outside world as if it was a full handshake, but you've just cached the computation. I like that. We've done that with the two keys from the server side.
So it'll have, however, inferior PFS properties.
Yes, absolutely.
To the existing document. Yeah, sure. So no, but I mean,
yes,
sorry,
you will compromise the existing
document, right? The existing document, the possibility of resumption does not represent a threat to the initial session head. And I think the way Adam described it, it does.
Yes,
I've been
no,
thinking
right.
while we're talking, how to
Yeah,
fix that.
that is a problem.
I'm not sure how.
Yeah,
Because it depends on the entire session hash, right? Yes.
Yeah, I'm not.
And also in triple handshake issues for the same reason. Because now, if you're inferring properties on
then
the
you can do
the original handshake,
two randoms. You can replay the randoms as an attacker, and you can't play the client random, can you?
No. What?
No. Anyway,
I'm just worried about like the. I'm worried about what you won't be. I'm not sure you'll be able to think about with this. Is this the same way as you do regular resumption?
So yeah, so it's a significant reduction in forward secrecy to do this, right? Because the difference between saying all resume sessions don't have forward secrecy and saying your initial session doesn't have forward secrecy means it is now impossible to churn your keys.
That's what I was trying to say. Yeah, I agree with you. Unfortunate, because it's a good idea.
Yeah. So the only option there would be that the server would have to not create these tickets, and that's something that the client would have to explicitly tell the server and forbid the server from doing. So otherwise, you're back in the soup.
Both sides would have to decide to not keep these
right.
things around. Yeah. And neither side knows whether the other side is doing it or not.
Well, you would have to include an explicit signal from the client that said, no, and don't do it, and I won't do it either.
Right. Yeah, right. So I mean, geez.
It's bad.
Because DK's point is, I think, if I understand it correctly, is that as far as at least confidentiality, not integrity attacks, the server and the client both know that this key's only been used once, and the system doesn't have that property at all. Nor does session tickets does that.
Session tickets does have this property for the first connection. It's the resumed session tickets that don't have this property.
But those session tickets has the property of resumed connection in the new TLS 1.3 world, not in the TLS 1.2 world. The 1.2 world, because as long as that 6 tickets floating around, it's a threat to the original connection.
Right.
Right. So
but we have a win
right,
here.
exactly right.
And I don't want to lose that win.
I'm sorry, I think we're about anyway. Okay. So how we got in this situation, as I recall, was we were trying to decide whether to take Hugo's suggestion about going to a completely DH-based system. So I'm really hoping the chairs can drive that discussion to a conclusion. Because we've now discussed it twice, maybe 4 times, and I've been stopped discussing it one way or the other.
Should have gone. Yeah.
Well, we can try. Okay, so we can try asking a question about the DH-only handshake here. So it's kind of the OPTLS that's been described, and whether we want to go down that path. Eric has a proposal in a GitHub draft.
Right. I mean, I have a fairly complete write-up of this that you can go refer to at your leisure, though not now, obviously.
DKG, I just wanted to put a couple of clarifying points before we start a hum. The proposal that Eric has is all online signing. Yes. And then Hugo came up and had a more sort of generic overview that included some scenarios that don't have online signing.
So
is that
so
correct?
I think I would say there's no I wrote up there's no offline signing, but there's caching. That is, this is the point Adam and I were discussing earlier. Is the server required to sign every single time, right, or not?
Right, and the question is about for follow-ups for the 0 RTT case in particular.
Yes, exactly.
Or a failed 0 RTT, 1 RTT case, right? Whether the server is required to sign in those scenarios. Right. And if you allow the server to not sign in those scenarios, then you reopen the delegation question.
I don't think you do because the server needs to, because the problem is that every single in those scenarios, every single client needs to learn about the server's key independently with an online signature.
No, there is no delegation. The only signature that the client will trust is a signature that he received in an online interaction with a signature that included its nonce. So there is no way for the attacker to create a signature that any client will accept. The problem with delegation was that you steal one of these offline signed keys, and you can use it forever. Here, you get only the guarantee that the signature was fresh, so there is no delegation.
Hannes, I would like to request the chairs to carefully phrase the question because we had a couple of half-baked ideas flying around where we weren't quite sure what the issue is, and multiple different aspects being discussed. And presumably many of the folks in the room haven't looked at this GitHub sort of pull request either.
Yeah.
So
So to summarize would be online signing, okay? Meaning that we don't have the delegated credentials, and there's an optimization where you can go with a single ephemeral key instead of a static key and a shared key. That was described so that you can have the optimization. Yeah.
I'd like to get a sense of how many people think they understand the proposal.
Yeah.
As it's come out, you're talking about the online signing, maybe with caching for the GTDS. None of the discussion we had about resumption plays into that at all, I should hope.
Right.
And the key schedule and all those sorts of other things that we've talked about in the past. So I'd like to get a sense of how many people think they understand the trade-offs that are being made and have enough information in order to decide whether or not it's A or B.
Third question first. And also, who thinks they ever are going to understand this well enough to have an important decision? Because I don't want a situation where, like, there are 6 of us in the room who really have to deal with this issue, and other people are spectating, and they're never going to understand, and that's okay. But
Okay, so how many?
Before you do that, can I speak to what Eckert just said?
Go ahead.
Paul Hoffman. So one of the problems in the room is, regardless of however the hums go on who understands or not, it seems like many people from the front have been asking for opinions of browser vendors, server vendors, large content sites, CDNs and such like that. So it seems a little bit antithetical for you to if the hum goes towards people don't understand it, but we're going to go ahead anyways, to be asking those groups. I think it's fine to say only people who understand should be really, putting in opinions, but I don't think it's okay to say both that plus we want everyone's opinions on forward direction. And as what we've heard for the last 45 minutes is different organizations, and I don't mean that like vendors, but like groups of people have different desires, regardless of whether they understand where we are right now or not.
I'm sorry, I spoke badly. What I was trying to say is I don't want a situation where we're saying people don't have enough information to make a decision, but they never intend to gather enough information so we can never make a decision.
But they still have preferences for what they want, either on zero RTT or things like that, even if they're never going to understand.
Okay, I'm trying to get to an answer.
Okay.
Okay, so the question is going to be how many people understand the proposal that's in Ecker's draft? Okay, about how many people don't understand the proposal in Ecker's draft?
Is there something I can say that would help you understand it? Is there something I can say that would help you understand it?
You could scroll down.
It goes on for a while.
So, this is implementation of what I tried to express earlier. What part wasn't clear that I could help you be clear on? So if I wasn't clear, then I didn't understand how to be clear.
Yeah. So what I would like to understand better is to see the implications for the use cases I care about, which I hadn't got.
I don't actually think. I think for the use cases you care about, there are almost no implications.
That's good to hear.
The one RTT mode that be implied by this document has essentially identical performance properties to the existing one RTT mode. And the zero RTT mode, priming the zero RTT mode may or may not be more expensive but we didn't have the zero RTT mode anyway. So nothing is. I don't think anything material has changed for you.
What about this issue? If we want to maintain a performance on a server comparable to 1.2, that you lose zero RTT, just to earlier point that I raised.
Yes,
that's something that we lose, right?
So
consider that.
We'd have to decide at that point whether or not to. We have to decide at that point whether or not to say we're reusing the existing key or have a separate slot for the key, right?
Right. There's a way, I believe, to not have this compromise.
So as I understand what you're suggesting, what you're proposing is what the natural way to take the natural extension to the existing 1.3 handshake to enable zero RTT, which is simply a separate message containing the server parameters, correct? Right. So
you have to sign anyway, and you include what you want.
I think that is the primary alternative. And somewhere I have and I think at the interim I described having a draft for that too as well. So, like those I mean, maybe that's the way to think about it. The two things you're choosing between here are a mode in which are basically two essentially semi-decoupled protocols, one of which is a 1RTT protocol with a hint for 0RTT, or one protocol that is designed to have designed to be both 1 and 0RTT, but with some small knobs to make that supposedly make that happen. Feel free to characterize it some other way. I'm really trying not to bias the discussion. I'm trying to get accurate as much as I can. So feel free to characterize it some other way if that's not an accurate characterization.
Yeah, so Martin, I think I'd go further than you in saying you think it has the same performance characteristics. I think it does have the same performance characteristics as the other one. And the exact thing you use to get the 0RTT case in the signature mode, you can use the same optimization in this mode. You just have 3 keys then. It's not really all that much different.
It's just gross.
It's a little, yeah, you put a few more bytes on the wire and then we can make that decision as an orthogonal one, potentially.
I agree, that's true.
I think the point was that you lose your RTT, right? If you do mem copy in one RTT, that's one downside.
No, you can do 0RTT in the same way.
But you're going, well, you're essentially using a PFS from one RTT. So your semi-shared secret, semi-static secret is the one from PFS,
yes,
from one RTT, which is undesirable. Whereas with what I propose, you have, more or less static key sent to the client, and so it has essentially like a DH certificate available to it with identity binding like you described, but it's a fresh, completely independent share.
You can do the same thing in this proposal as well.
You have a cost. With this proposal, you have a cost.
No, that removes the cost. By doing so, bytes on the wire, sure.
Computation
cost. There would be.
Right. Okay. I see. So can you scroll back to the diagram? So let's talk about the air ladders.
Next.
Right. So in the current mode, this is initialized no payload, right? And in the and so now the suggestion is that a key here and a key here, and as you say, if these are the same, it's just as fast, right? But they have to be different. But they have to be different in order to find for 0RTT. The way you would have added 0RTT, the way you would have added 0RTT to the existing handshake was to add one of these messages in the middle, right? It was basically have a short round message you shoved in next to the certificate verifier, close to the verifier, right? Yep. And so what you could do, not to this elegant, is you can have 2 of these messages. One of which is this is my first handshake, and this is the second handshake, and the first one has the same value here, and the second one has the. I am not saying it's elegant. I was trying to get that earlier, but you can do it.
Complexity, one word.
I don't disagree with that. And basically, what that basically does is, so one way to think about this is you're pushing that physical complexity around, right? Is that physical complexity being pushed around is that the idea was to have only one logic here, and that the cost of that is pushing that complexity into the primary, right?
Okay. Oh, go ahead.
Looks like the early discussion went that some vendors will not implement 0RTT, and you think about that segment, that it is a major change for them. They have to deal with performance penalty unless they mem copy, sort of be aware of that. So from this point of view.
Right. So to restate what I think you said is that in the mode where 0RTT is just graphed on to the existing 1.3 1RTT handshake, then the performance cost of enabling 0RTT is basically zilch, right? You just create this thing, you shove it in your handshake, and you're good to go. And in the DH-based case, it's possible to get into this state where you have to like try to decide, okay, should I be like putting this thing in here and using the same key in both places, or should I be like, and accept extra exponentiation, or should I do like the two keys in both places and then put the message in, and so it's more, and it's like it's possible to get yourself in these weird states that are sucky, and you have to think about it really hard. I think that's fair. I know this, guys.
Try to write down the question that you're going to answer.
Yes.
Just saying that, or what's in the document that Eka pushed upwards, I think that's not a good question to ask. Trying to formulate the question, and you will see it's more complicated. And I think also asking a security room whether they understood the question, where people always feel obligated that they of course understand, because otherwise it's embarrassing, is not the right question either. I think half of the people who raised their hand that they previously knew what was going on here actually were dishonest.
So I just want to say that the issue of how you exactly transport the G to the S or G to the Y in this optimized mode has the exact same performance complexity of doing it in the regular signature way. So there is no performance gain there. It's exactly the same. It's all about really the simplicity of how you specify. And for example, if you specify that you don't repeat G to the S and G to the Y, but you only say, okay, in the optimized version, I don't send the G to the S, but I only use G to the Y, then, and you want to send the G to the S for the future, then you get exactly the same thing as you are proposing. So there is nothing fundamentally different here, really.
Eka just clarified a lot for me. The question is whether we support Hugo's proposal or not, and my answer is yes. But nobody said that before.
I was trying to give a concrete instantiation of your proposal. Maybe I failed.
Well, so we can ask the question. I think we're going to have to take something concrete to the list.
Yeah, I mean, everybody who raised their hand, if you're on the list, we're probably going to have to take it to the list, unfortunately. And so then, you know, we should comment on it there after we formulate the actual question. But I thought fundamentally what we were trying to figure out was whether there's support for even moving to Hugo's proposal for OPTLS, which is a signature list-based approach. So that's a simple thing, but the people that didn't, well, you know, I mean,
so Martin Thompson, I just want to get a decision on this point that we've had come up for the past 5 meetings or whatever it is now. I want to walk it. Let's just keep clarifying, sure.
No, it's not correct to say this was discussed during the past 5 meetings, because if we talk about Hugo's proposal was brought up in the intro meeting in Paris. That's not 5 meetings away. And it was clarified, and then now you had a couple of other fine variations, and so maybe put up Hugo's slide, and then ask the question of which variations, or all of them, or only a subset of them we are going to talk about.
20 questions.
Does that make sense?
No, I think it's like 20 questions.
Stephen Farrell. So what's the impact of not deciding today on the timeline and for editing the document and so on? I think that would be interesting to know.
Yeah, I mean, it's starting to really interfere with my ability to edit the document, to be honest. I mean, the problem is, like, when you start to write the 0RTT thing, then you need to know how the 0RTT thing is primed, and that means, having some of these answers, and it means having to have the key schedules. I mean, I can continue to make some progress, but it's starting to really get in the way.
So my sense is that there are some small things you can do around the edges. but within about a month or so, you'll run out of those things.
Right. I mean,
and
yeah,
we'll be back to this again.
I mean, so to be direct about this, the key schedule that we're going to need for zero RTT needs to be written down somewhere. And if we're going to do, and I can write it down for either of these variants, but I can't write it down for neither of these variants, for not knowing what these variants are. And so I'm going to have to do, and so if we don't have this answer, I'm going to like duplicate, like, you know, I'm like write invent some totally new zero RTT key schedule, rip off from the one in here, and put that in the document and say, well, this is the one we use here, and there's another one we use here. It's going to be like really a mess, right? And then it's going to be all those question marks on the other thing. It's like, no, we have to resolve it.
I also think we should resolve it. I'm also in favor of moving towards the cleaner, simpler proposal, which is, I think, Hugo and Hotek's current proposal. So.
All right. So I guess I'm going to ask the two questions, right? Whether we're basically in favor of moving to a signatureless based TLS version based on Hugo's proposal, right? Lots of caveats in the whole 9 yards, or not.
Sure.
Okay.
I guess I prefer to be more concrete about the thing I presented earlier, which I think is actually reflects the parts of your proposal that there was more consent. There's sort of semi-consensus in the interim, because I know you guys have a lot of ideas, and I want to make sure which ones are current or not. That's too strong. Like, you know, I thought I was clear. I thought I was clear on what I was suggesting.
And the pull request, basically.
Yeah.
Yeah.
I mean, clean it up, maybe, but the pull request.
Which is what we're going to
Yeah, which is where we started off, yeah. So, I mean, basically it is, you know, hopefully you read it, you did your homework, right? So I'm going to ask those questions and see where it goes, all right? So please hum now if you would like to adopt the signatureless based proposal based on Hugo's input on the pull request, the whip in progress number, the pull request number 90. Please hum now. Please hum now if you're not in favor of doing that. There's pretty clear consensus to go ahead and continue to work on this and pull this stuff in. But we'll obviously have to, yeah, so this definitely, I think there was at least rough consensus to go ahead and adopt this. Obviously, we're going to have to go ahead and take it to the list. It's going to be quick. We're going to do like one of these 2-week things, like speak now or forever hold your peace.
I will produce a revised version of this PR and write it to us.
Can you check if those against any new arguments?
Yes. So again, so is anybody who hummed no and feels like they want to get to the microphone and add anything new that we haven't already discussed? You can wait to do it on the list as well. All right.
Okay. Okay. Oh God.
So yeah, I mean, this is over at 11:30, so we got 12 minutes. Yeah.
How would you do the rest of this time? Shall I continue?
Yeah, I guess I think so.
Okay.
Yeah, as long as you're okay with that, Andre, right? Okay, all right.
We discussed, at the interim, we discussed moving to HKDF. So TLS has a sort of ad hoc PRF based on hashes, and we discussed moving to HKDF, or modern hash design based on, I believe this is called extract and expand. This RC5116, there's also in this SP, which I don't remember, is it 856C or something? Which is different. I stand. Good. There's nothing really, as far as the best of my knowledge, and we have to do your thing to correct this, there's nothing actually really wrong with the TLS PRF, but the theoretical construction is not. And then HKM it represents the theoretical property we'd like to have. And so we don't have, the draft pull request I put in had HKDF in it. And technically speaking, these are orthogonal questions, but if we're going to do this, it's like a lot easier for me to do it now, because I remember a bunch of stuff we put it in. So
I guess I would characterize the conversation when we had at the interim when this first came up was, we should do an HKDF. Yeah, that sounds like a good idea. We should all do that. Like, no one thought it was a bad idea. So.
Yeah. Am I not loud enough, or too loud, or what? Okay. Oh, okay.
So I guess I'm curious to know if anyone feels like that we should not do this, and if you're willing to get to the microphone to speak about it. Because we know we don't think there's anything wrong with the PRF currently, so it's kind of moving to a more, modern construct.
There was some this opinion that we have to move beyond NIST algorithms, things like Cha-Cha and Poly and all that. And then if you take HKDF and take SHA-256 with it, we're staying with NIST stuff. That's kind of comment I got on similar things at IPsec. I mean, they're not really good arguments.
So my assumption had been that we were going to continue with the present pattern of each cipher suite had to specify their own PRF, and underlying PRF hash function, and so that would not change. I guess that's another final question. We certainly could say that the existing, and they're both hash-based KDF. So we could certainly say either HKDF could be used with any hash function the same way the existing PRF is, or we could restrict the existing PRF to only be used with SHA-256 and SHA-284. So I mean, these seem like final questions to me.
So we can tell the authors of the Cha-Cha or whatever draft to add their own, add whichever PRF that they want.
Though I'm going to oppose that when they ask for it.
Yeah, we might.
I would suggest that even the Cha-Cha draft, we wouldn't want to. Like, we're not doing Cha-Cha because it's not NIST. We're doing it because it has properties that we like over than AES-GCM. But I don't think there was anything to dislike about HKDF.
Yeah. All right. So.
One word about the question, is there anything wrong with the TLS PRF? So what is suboptimal in the TLS PRF, if you want to use it as is that you would be keying, using keying the PRF with a secret that is not necessarily uniformly random. So you would be using, for example, the output of a Diffie-Hellman or, I don't know, a passphrase or whatever the secret comes from, and you will be putting it as a key to the PRF when PRFs are analyzed only as under the assumption that the key is uniform random. So that is the extract stage in which you take the secret entropy in whatever secret you have, and you extract it, you concentrate it in one key, a PRF, a pseudo-random PRF key from which you can derive more keys. So it's only that part of, so in the RSA case of TLS, there was no problem because TLS transmits a random value under the RSA encryption, and so what you are keying the PRF is with a random, uniform random key, so that's fine. But when you start doing other type of keying, then there is a question there. So beyond the security or the cryptographic analysis aspect of this, there is also the issue of formatting. If you have a 512-bit secret and you want to use it, for example, for a PRF with 256 bits, then what do you do with that? How do you go from 512 bits to 256 bits of key? And this construction solves also that more practical problem. Other than that, actually, the not extract part, the expand part of HKDF is exactly what was used in TLS all these years, which is basically a PRF based on HVAC.
So do you have anything to add to this, Ecker?
Not that it's important.
All right, so we're going to ask two questions, right? This is, the first one will be whether you believe we should move to an HKDF-based PRF, or whether we should stay with the current approach. All right? Please hum now if you would like to move to an HKDF-based PRF. Please hum now if you would like to not do that and remain as is. Done.
Okay, next slide. Okay, so final thing we'll talk about is the initialization vector / balance for AEAD, which we can, I'm sure, do in 6 minutes. As you'll recall, the existing AED cipher suites, the GCM cipher suite has, so every AED cipher suite requires a nonce of some length, although maybe 0 is an acceptable value. The existing GCM cipher suites have a randomly generated ID that comes off the master secret on the top 32 bits that is fixed to the entire connection, and then a 64-bit explicit, which is may or may not be the block count, may or may not be the record sequence number, and then there's a 32-bit block counter which is run inside the algorithm. Obviously, carrying that 64 bits around chews up bandwidth for no necessary security value, but the reason it was put in there was because it made it simpler to do the analysis if you assume the crypto module generated the IV. But last time we discussed Cha-Cha, we came to the conclusion that as long as you required it to be the record sequence number, and the module could then just count forward, so it wouldn't be that big a deal. And that was, and I'm pretty sure that was clear for the people who wanted the original explicit value. So I think we're all happy. So it'd be great to have, in 1.3 everyone behave identically, rather than having Cha-Cha and GCM differently. Next slide. So in the interim, we just discussed using the record sequence number and padding the zeros to the left. Brian Smith on the mailing list argued that this had the consequence there was an enormous amount of plain text that was going to be encrypted with different keys, but always with the same nonce value, and that was not good. So after doing something for diversification, there are basically 4 options I'm aware of here. Do nothing, that is, continue to pad the zeros. Have a per session prefix the way we're doing now, that is, say, like 32 bits of random and then a counter, which would be what Cha-Cha does, I believe. Or Brian is just a per session offset, where basically you'd say, here is I think as long as you need it, but 64 or 96-bit value, and then you just add the sequence number to that. And I suggest on this having a per session XOR mask, which you XOR the sequence number with. These are the 4 options I'm aware of. We should do one of these, because again, that might come right in the draft.
Yeah, so Martin Thompson, TLS has a history of sort of patching over perceived shortcomings with its underlying crypto primitives, and I'm not sure that it has a good history with doing that. I'm not convinced that that any additional random stuff is necessary. All it really serves to do is do this sort of patching over. I propose you do exactly as you propose to do at the interim, which is essentially it is the sequence number. You pad out to n-min if as necessary, and we trust that AES-GCM actually is doing its job.
Adam Langley. So yeah, the concern here is that if you have AES 128 bits and you happen to see a huge amount of the internet, say 2 to the 60 sessions, you may be able to sort of like find 2 sessions at random amongst these that sort of randomly have the same key if you do enough work. So if you want to defend against that very remote possibility, I would suggest the XOR for a reason that Eka said this morning, which is that if you have a random offset, then you have to expect software to deal with overflow of the counter, which sounds error-prone and unlikely to be good. And the per session prefix, then we have to worry about, well, does the AAD have a large enough n-once that and it probably doesn't matter, but yeah, whatever. So I would suggest either 1 or 4.
Mike St. John's.
Mike St. John's.
As long as we're using different keys in different directions and we're only using the key for one session, do nothing works. I mean, that's really what it is. If we wanted to basically say we're only going to generate 1 key per session, use it in both directions, doing a different prefix for each one of them would be semi-efficient for something like IoT, for example, because you wouldn't have to keep reloading and redoing the key key schedule stuff.
And Martin Thompson, there is one final option for people who care about this sort of thing, AES GCM 256.
So, I mean, I'm willing in the last final minutes here of this thing is to just go through each one of these 4 options and just ask what people think.
I don't have anybody speak up for number 2, so I think I could
Punt number 2? Oh, we did? All right.
Yeah, sorry, actually, I got one more thing. One of the assumptions here, by the way, is that I just realized is we're making an assumption that the block to be encrypted by the counter modes is always going to be 128, which is an AES thing, but may not be an AEAD thing.
No, we're assuming that n-min is at least 64. The AED interface just assumes you pass in a nonce and n-min at least n-min. We're assuming that is 64.
We're assuming n-max is at least 64.
That's not where it is.
We can provide. We're assuming we can provide 64 bits to the AED.
Yeah.
That's what we're assuming.
What I'm saying is that if the block to be encrypted is 256 bits, right now the block to be encrypted is 128 bits. Right. And I'm sorry.
We can make that work. That part will work.
Just it's a language thing, not a.
Fair enough.
All right. So thank you for staying late. So I'm going to ask 4 questions on this issue. They are running down through the options, which is, please hum now if you do nothing, prefix, that yada, yada, yada. So, please hum now if you think that we should do nothing with this issue. Please hum now if you think we should do the per session prefix to solve this issue. Please hum now if you think we should do the per session offset. Please hum now if you think we should do the per session XOR mask. I still believe there was consensus to do nothing. The first option we discussed. Thank you. Have a good day, folks. We're going to take a bunch of stuff to the mailing list as well. The do nothing option for the AAD. No, I mean, yeah, so read the EC draft that we're moving to standards track, folks. We need input and lots of other things.
Sequence number and pad with zeros?
Yeah, let's do that. Well, EAPTLS is probably not because it doesn't. You would never but for TLS in theory,